engaged in silly Olympic and world records tumble. Italian Air Force jets collided mid-air. At least 46 people were killed and several hundred injured.
Events around the world are brought to the notice of villagers even in remote areas. How is this made possible? Communication satellites around the earth are responsible for this revolution in communications. India has a system of communication satellites called Indian National Satellite System, or INSAT. It is designed to meet our requirements of telecommunications, TV broadcast, and weather forecast or meteorology. Let us find out about the main features of the INSAT system from the chairman of Indian Space Research Organization.
We felt that the country needed to get into the communication area as quickly as possible, and therefore we conceived of a unique multi-purpose satellite system, INSAT. It is unique in many respects, probably the most unique in the world today, since it can carry in a small bus a large number of experiments and large number of services this can provide. The first 4 satellites, 1A, 1B, 1C, 1D, were essentially designed by Ford Aerospace. We went out till we developed our own technology. But the basic concept of utilizing a satellite for providing multiple services was ours, and the Ford Aerospace built this satellite to our specifications, and they have been, of course, launched from other countries, since we still do not have the launching capability for launching satellites of this class.
But before finding out how an artificial satellite is launched, let us see what a natural satellite is. It is a heavenly body revolving round a planet. For example, the Earth is a planet and the Moon is its satellite. The path of the Moon is called its orbit. INSAT is an artificial satellite. Let us see how it is launched in its orbit. You are familiar with the Diwali rocket. The gases coming down from this rocket push it up. Likewise, the rockets attached to the satellite carry it up into space. A satellite follows a series of paths before reaching its final orbit. The launching operation accounts for nearly 3/4 of the cost of any space venture. To maintain constant communications with the ground station, INSAT is placed in a geostationary orbit. Before explaining the term geostationary orbit, let us look at this picture. You can see that the wheelchairs are moving, but they are stationary with respect to each other. Likewise, the Earth rotates in its axis and INSAT moves in the geostationary orbit. INSAT is stationary with respect to India. A geostationary satellite takes 24 hours to complete one orbit around the Earth. Although stationed over India in space, INSAT can cover a vast portion of the globe. In fact, with just 3 such geostationary satellites, we can have communications over the whole world. geostationary satellites go round the Earth at a distance of 36,000 kilometers. What you see here is the model of INSAT. Some of its main parts are solar array, antenna system, and very high resolution radiometer known as VHRR. Solar array converts sunlight into power. Very high resolution radiometer known as VHRR helps in weather prediction. Antenna is meant for reception and transmission of signals. Although INSAT is launched abroad, it is maintained in its orbit by Indian scientists. This is done by using master control facility at Hassan in Karnataka state. For constant communication with ground stations having fixed antenna, the direction and position of the satellite in the orbit must be maintained properly. You are naturally interested to know how our scientists are able to control the movements of INSAT, which is 36,000 kilometers away from us. To understand this, watch this sequence carefully. The satellite seen here is not properly directed towards India. To set it right, a remote command is issued from Hassan. This causes the firing of small rockets from the body of the satellite. See, it is now being brought to the correct position. For the purpose of firing rockets in different directions, there are thrusters on all sides of the satellite frame. You see two of the thrusters here. In order to understand the functions of INSAT, we must be familiar with some terms used in satellite communication. For example, we often use the term Earth station. An Earth station transmits signals to or receives signals from the satellite. From now onwards, we use grey antenna facing upwards as a symbol for an Earth station. Another term used often is uplink. Uplink is the communication link between the transmitting Earth station and the satellite. Now, what is a downlink? Downlink is the communication link between the satellite and the receiving station. For uplink and downlink operations, Earth stations have been established all over the country. The Earth station for Delhi is at Secunderabad in UP. Let us now see how INSAT transmits telephone voice, weather data, and TV signals across the country. We denote transmission of voice by a phone, data by a data processing machine, and TV signals by a TV set. The voice, data, and TV signals are sent to the nearest Earth station. It modifies and beams these signals to the satellite. The satellite then strengthens, modifies, and transmits these signals to the receiving station. The receiving station processes and retransmits the signals to the user locations. At the user location, signals are reconverted into voice, data, and video. This then is the basic principle of satellite communication link. But you must bear in mind but all these communication links take place simultaneously and individually. Satellite components like antenna and transponders are vital in this communication link. You have seen antennas on the sides of the satellite frame. These antennas receive and transmit the signals. This is the rear portion of the satellite model. You can see the transponders located at the bottom and upper portions of the frame. The signals received from the Earth station are very weak. The satellite transponder has a key role in strengthening these signals. After modification, it retransmits the signals through the antenna. These modified signals are received by the Earth station. Using these ideas, you can understand the role of satellite in the relay of the National Network Program. The TV signals from Delhi Doordarshan Kendra are transmitted to the Secunderabad Earth station. From here, these signals are beamed to the satellite. These signals are strengthened and modified by the satellite transponders. They are then beamed down to the relay stations. From here, through local transmitters, signals reach the domestic sets. To facilitate TV broadcast in remote areas, thousands of direct reception sets have been installed. These direct reception sets can directly receive signals transmitted through the satellite and then decode them into picture and voice. INSAT also has a pivotal role to play in distance education. UGC's countrywide classroom is one of the educational programs viewed throughout the country thanks to INSAT. How far has INSAT increased TV coverage area? Let us find out from the ISRO chairman.
In terms of TV broadcast, we had hardly about 10 to 12 TV stations in the country. Today we have 280 TV stations, low power transmitter stations, out of which except for 6, all of them are dependent upon the INSAT system. They cover over 70% of country's population, which is likely to increase to 500 transmitters in the next few years so that we can cover 90% of country's population. In addition, we have what we started in the site, 8,000 community TV sets dispersed in remote areas. We have started regional language services.
Let us now look at the role of INSAT in weather prediction or meteorology. Every night in the TV news bulletin, we see cloud imagery obtained through INSAT. This cloud imagery is obtained from the digital data supplied by Very High Resolution Radiometer or VHRR. In the INSAT model, you can see VHRR in front of the white boxes. VHRR collects cloud picture data using visible light and infrared rays during daytime. At night time, only infrared rays are used. Mosam Bhavan Delhi has a meteorological data utilization center to process VHRR data. INSAT meteorological data are analyzed and stored here. It also transmits these data to other centers. VHRR data helps us in prediction of day-to-day weather, including cyclones. Prior to INSAT, weather data covering entire oceanic regions were not available. INSAT is particularly helpful in the early prediction of cyclones. What you see here is the computer simulation of the movement of the cyclone of November 1988. The cyclone originated from the Bay of Bengal and finally hit Bangladesh. Through the fury of wind and water that causes monumental loss of life and property. At least loss of life can be avoided by a timely warning. INSAT helps in this direction also. INSAT helps in flashing cyclonic warnings directly to the areas likely to be affected using a coastal setup known as the Disaster Warning System. Let us now see how the disaster warning messages issued from Madras selectively reach different coastal areas. The signal regarding cyclone warning is transmitted by the Cyclone Warning Center at Madras to the Earth Station. The signal is further transmitted to the satellite. The satellite then beams the signal to the local disaster warning receiver. On receiving the command, the local disaster warning system starts a siren. On hearing the siren, the local people gather to hear the cyclonic message, which is read out in the local language. This system helped the authorities to take timely action during the October 1987 cyclone in Tamil Nadu and Andhra Pradesh. Another major achievement of INSAT is that it has enabled collection of weather data from remote, uninhabited and oceanic regions. For this purpose, data collection platforms have been set up in 100 places. We have data collection platforms in the Himalayas and even at the Indian base station in Antarctica. In the Yamuna catchment areas, data collection platforms have been established for forecasting floods. A data collection platform is an unmanned observatory cum data relaying station. It has instruments to collect weather data like wind velocity, wind direction, rainfall, and temperature. You see solar cells fixed on boards here. Power generated by these solar cells helps in transmitting weather data as signals to INSAT through the yellow antennas pointing upwards. These data are transmitted via satellite and Delhi Earth Station to Meteorological Data Utilization Center for further processing. The weather data so obtained from VHRR and data collection platforms supplement data obtained from conventional observatories. These weather data are globally transmitted since weather knows no boundaries. Further, these weather data are helpful in the fields of agriculture, aviation, and navigation. In a nutshell, INSAT has increased the confidence of weathermen in forecasting weather. There is much more data available now than in pre-INSAT days. So, we have seen some of the functions of INSAT. What is the source of its power? You can see solar array and battery in the model. The solar array provides power using sunlight. The battery is used for power during days of eclipse. Indian Space Research Organization carries out its space program, which is a multi-crore rupee project. How far is it cost effective in a developing country like ours? Professor U.R. Rao will be able to tell us.
I think the space program in this country has paid for itself. 2 years of revenue from a satellite like INSAT pays for the entire INSAT program, whether it's through Doordarshan or with revenue earned in the telecommunications and so on. Worldwide, if you see, in spite of the large inflation that has taken place over the years, the only thing which has not increased in its cost is the communication because of the satellite technology. Notwithstanding, everybody is making profit today. Now, in terms of the meteorological resources, for example, meteorological applications, for a country which is agricultural based like ours, now the computation of the actual benefit cannot be just measured easily, quantified, because it goes into the entire agricultural production. Disaster warning, for example, saving of the lives, one can ask what is the cost of life. Information system, which again can't be quantified in terms of its revenue, but its effectiveness in finally essentially allowing us to develop this country in a rapid way. Education. Now, of course, you don't get money by educating people, but on the other hand, educated people, everyone is an asset. The question is, what value you add to that? And do we have any choice of not using such a technology which has complete transparency to the remote areas, rural areas, and the only way you can develop this is through such a technology. But even in terms of hard revenue, what is earned by Doordarshan today, as well as the telecommunications, alone pays for the entire INSAT program.
At the moment, we have a great deal of foreign collaboration in our space programs. When will we in India be self-reliant in space research?
The second generation INSAT, which is even more complex than the first generation, is already being built in the country after having now gained experience in building satellite technology. Over the last 12 years, we have built 8 satellites indigenously. This is in addition to the 3 INSATs which have been launched and which have been procured from elsewhere. And the latest IRS satellite, the Indian Remote Sensing Satellite, which was launched in March of 1988, is a state-of-the-art satellite, comparable in its complexity and service to the best that's anywhere in the world. And therefore, based on this experience, the second generation satellite, INSAT-2, which will start flowing into the mainstream from 1990 onwards, is all being built here in the country. In terms of technology transfer, in these high technology areas, it is not possible to obtain technology from elsewhere. Therefore, we have to build ourselves. And the entire technology which has gone into INSAT-2 is the indigenous technology, just as the technologies which went in terms of the Apple or Aryabhat, Bhaskara or IRS. In the earlier satellite, we did buy some subsystems from elsewhere, but gradually even these subsystems, and more importantly, systems like the inertial sensor system, control systems, and the thrusters, and the camera, now are all being built in the country. And these have been developed. Therefore, gradually, our dependence, even on procured subsystems, has gone down enormously. By 1994-95, I am confident that with the dedicated work that is going on by my colleagues, we would have the total capability to launch our own satellites. Today, we can build our satellites, however sophisticated it is. We know the applications, we build the ground systems, And through this process, we have passed a large number of technologies to the industries in the country. Over 180 technologies have been transferred. Today, 55 to 60% of our money, which is spent by the Department of Space, is spent within the Indian industry. And that, I think, tells you what the type of self-reliance which we have achieved. And in the rest 40%, of course, includes salary, administration and so on. It's not that all the 40% is going outside. Salary, administration and the management, these are also included. Now we certainly are trying to push this higher because we are convinced that industrial growth is the backbone of the country. For example, today, all our propellants are made in the industry, whether it is public sector or private sector. The satellite structures are built in HAL. The payloads are built everywhere. And over 300 industries in the country are integrally participating. And this is the measure of the self-reliance, much more than building within ISRO.
What we have seen here is only a fraction of the services that can be provided by INSAT. INSAT itself is only a portion of India's space program. Starting from Aryabhatta, we have a long agenda for an exciting space program.